Okay, guys. This is a review here for the ACS exam, and those questions is like taken from the ACS guide. There is a guide, study guide there. They give it to Principle of Chemistry 1, Principle 2, and up. And the Principle 1 is very close to whatever we have in Survey 1. So I'm giving you this question here. I want to convert 1,250 ml to liters. So let's start. So I'll give you 1 minute or two. Tell me which answer is correct. Which answer is correct, guys? Don't let me down. Let me Okay, guys, which one? Don't open the iCollege and look and cheat on me here, please. Please don't do it, yeah. Everybody, don't do it, please. Yeah, don't play smart on me, correct? Yeah, okay. No, they are there. You don't see them? Just hold on. I'm trying to get this my okay. Okay, so here it is. So somebody will tell me how to do it. So first of all, we have to watch for the sig figs. So the number we are converting, how many sig figs does it have? 3, correct? No decimal. Therefore, the last 0 is not significant. So there is missing the second condition. The first condition has to come after whole number. This is coming after 5. And the second condition, the decimal has to be present, which is missing. So therefore, this 0 is not significant. So we have 3 sig figs. So in order to get around this one here, just the method I showed you before. So I will start with 100 to 50 ml. It is. Yes. You can see. Well, I don't know what's happening here. So I can see it from my part and you can see it in your part. So, well, so let me, maybe I will, let me see. You can see because, let me see. Maybe I will be, oh. Now, can you see it? Can you see that? Okay, guys. Let's hope I can write it there. Let's hope I'm allowed to do it. So 100, 125 ml. You can do it, with brackets or parentheses or table. I like table. It's easier. So 125. What should I put in the bottom to cancel? The ml, correct? And then I have to go through the basic unit of the length is liter, correct? However, this milli is 10 minus 3, correct? So with number I have to, with exponent I have to put in front of this? 10 plus 3. 10 plus 3. Everybody agrees? That the m is milli, 10 minus 3. I have to with the opposite of the exponent, correct? You remember that? So then I have to 1 liter here to cancel the liter. And then I have the micro liter. 10 micro is 10 minus 6. What should I put in front of it? 10 plus what? 6. Correct? Now let's look at the cancellation of the units first. Milliliter, milliliter cancels out, liter cancels out. The only units left is what we are looking for, microliter, correct? Now, I will not do anything else. I put the number as is 125, so the answer is here 125, 0. Then at the bottom is 10 plus 3. I have to take the bottom up, will be 10 minus 3, correct? This is 10 plus 3 goes up, 10 minus 3. And then in the top remains as is 10 plus 6. So if I look at this, 1, 2, 5, 0, 10 plus what? Plus 6 minus 3, how much? Plus 3, correct? This is the answer here, and the units is microliter. Now let's see if the where is the value here? What's correct? Which one is correct? Which one? Convert this volume to liters. Oh, this milliliters. What we did? 125 milliliter. It has to be converted. Convert this volume to liters, microliters, and cubic. 3 things, but we will do it as a microliter. It's not there, but we will do it. If we get it once correct, then the other ones, we can do the whole thing. Cubic centimeter is milliliter. Okay, cubic, this one here, centimeter cube is 1 milliliter. Correct? So, how much is 125, 0, 10 plus 3 microliters? So, how much do we have one is here? We don't, correct? 125 microliter. This is not correct. It's the power plus 3 is not there. So, which one will be correct, guys? Which one? A, 125. This one. Let's do the microliter first. How many we have? 125. Here it is. And this is 10 plus 3. Correct? So this is the value here. And the 3 zeros are 10 plus 3. So A will be the correct one. But let's do it in liters. If we want to stop to liters, I have to stop here. This is for liters. I have to stop what? Correct? To liters. So will be 1,250, 10 minus 3 in liters. Correct? Here it is. In liters will be, transfer it into liters will be 1,250, 10 minus 3 liters. It's 1.25, correct? 1.25. Everybody agrees? So that's here is correct. That's here is correct, correct. And the milliliters then, what will happen to milliliters if I want to transfer this one here to milliliters? So 1 liter is 1 milliliter. So this is liter, correct? So 1 liter here at the bottom, liter cancels out, and then 10 plus 3 milliliters, correct? Liter cancels out, will be 125, 10 plus 3, 10 minus 3 cancels out, 125. That's correct. Okay, guys, you know how to do it? Okay, so the answer is, I'll take the picture here. The answer is A, correct? That's correct. So let me take that second one. Okay, give you 1 minute to do it. A sample weighs 35.6 pounds using conversion. Here is the conversions given to you, and that's typical ACS exam. Whenever you change metric to English, English to metric, that will give you, or to SI, that will give you the conversion. But within the metric, you have to memorize all those 10, the exponents. You have to memorize this exponent, not given to you. 10 minus 1, 10 minus 2, 10 minus 3, 10 minus 6, and so on, 10 minus 9. So, what's the answer? I don't know. You know how to do it, correct? So, let's do it. Show me what's the answer will be. You start whatever is given to you. That's what you start. And watch for the sig fix. 35.6 pound, correct? Over 1. And then here is the pound. And in the top is kilogram, correct? Kilogram, 1 kilogram is 2.20 pound, correct? And they need, what is the mass in kilograms? So this one here, pound, the pound cancels out. You have 3 sig fix here, 3 sig fix here. So your answer will be 3 sig fix, correct? Okay, correct, guys? 1 kilo to 20 pounds. Okay, so how much is it? 16 point. The answer is B. Let's see if you are correct. But don't cheat on me here. The answer is B. Correct? You can see it. It's more tiny there. I'm hiding it from you so you don't. So that's correct then. That's correct. Let's do this one here. Second one. And for most of you, the conversion is very difficult, and I saw that even at higher chemistry classes. It's very hard on the students, this conversion. So now it's here. The scientist measures length and width of rectangular metal plate as 12.47 centimeter and 5.2 centimeter, respectively. Calculate the area of the plate, applying the rules of significant figures in multiplication. Now, you have the length is 12.47 centimeters. That's 4 sig fix, correct? How many? 4 sig fix. However, the width, I think, is 5.2, 2 sig fix. And if you do multiplication or division, then the least sig fix will be the controlling factor there in the answer. So, what will be the answer? 64.8. Okay. The area is always, remember that, the area is always a square unit of any square, correct? The area of the volume is always cubic of any units. Are you following me here? Centimeter cube, meter cube, whatever. So cube is always volume. Square is always area. So you multiply those together and the answer has to be, yeah, that's easy because that's easy. Why I did not do any calculation? I don't need any calculation here. Why? Because I'm checking on the sig fix, correct? All of them are 3 or 4 or 5. The only sig fix correct without calculation is D, correct? All those are off. It's not correct sig fix. So the answer is D. So let's not cheat. The answer is D. Can you see it there? I'm hiding that. So okay. So let's take this one out. Yeah. Consult your team. Consult your team, and then if you have any questions, stuck anything, just let me know. So it's a teamwork, correct? So okay, now this is a lab question. Might appear in the lab today, not to, yeah, I mean this week with the Wednesday lab, my Wednesday's lab. So this is ACS type of study guide. Might appear similar to that. So what is this graduate cylinder or burette reading? What's the value here? And remember, you have to have 2 digits after the decimal. I told you. Remember the burette? Read, you have a decimal. After the decimal, you have to have 2 digits. Correct? And the graduate cylinder and the burette reading always 2 digits after the decimal. So my intuition will tell me, my intuition, listen, without looking at this, my intuition, I taught you, I have to have what? 2 decimal. So I ignore this one here, correct? I ignore this one here. Those are out. Are you following me here? So those are not considered. So then I have B or D. Let's go and check. This is 20, correct? You go up. This is 20. This is 5, correct? 22.5. So 6.8, that's not 6, that's 5. And then estimated in between this, see here? Yours is here. You estimate in between this about 5 or 5.5 or 5.6 or 5.7. So the 7 is always the source of error. The last digits in the reading is always the source of the error. So I have to estimate it 5.7 because you cannot. The scale does not show if it's 7 or 5 or just estimated. The last one, the 7 is estimated. So the answer is what? D. Do I do anything? No, I just eliminate any things is not really studied or not recorded. We have to record this 2 digits after the decimal. Anytime I have 1 decimal after this is not correct. This is not graduate cylinder. Let's see if we have correct. Do we have correct? Yes. Okay, guys, the answer is correct. This might come in the final exam because through the whole thing, through the years, they bring one of those type of reading. Remember, eliminate those with the 1 digit after the decimal. That's out. They are out. Only the ones with 2 digits will remain, which is B or D. Now the D is 6. We don't have 6. We have 5. The 6 is here. See the 6 where? This is 6. Far off. This is 6 here. Far off. So, okay, guys, make sense? Okay, good. Okay. What's happened here? Okay, so. Okay, so the answer is correct. It's D. Now here, let's do this one here. What is the correctly reported mass of H2O based on the data in the table? Okay, guys, this is, they need the mass, correct? Mass of the beaker with the H2O, mass of the beaker only. This is significant figures problem. Why significant figure problems? This is because you have to look in the previous question. We have looked at what? We have looked at the division and multiplication. Here we have to have addition and subtraction. So I have to subtract those 2 values from each other, applying what I have to subtract 29.62 minus the beaker only 28.3220. Now, in the rule of the addition and subtraction will be the least digits after the decimal. This one has 4 digits, correct? and this one has what? 2 digits. So now elimination. This one has 3. Then this is out. This has 4. This is out too. Then this is 1. This is out. Did I do any calculation? No. This is my answer. I just looked at the digits. One is 2 digits, one 4 digits. The least this one has to be correct without looking. Are this following? Make sense? That will save you a lot of minutes of the 60 minutes you have in total. Because don't waste your time, do all this in details. Just look what you can expect your answer might have, and then my answer has to have 2 digits after the decimal, and all those digits, so I just keep them out. So the answer is B. Everybody got that? Let's see. Yeah, the answer is B. Today is our lucky day, so well, it's not bad. But still Monday though. Still Monday. Yeah. So answer is B. So let's do this. Density of helium is this: 0.164 kilogram per cubic meter. Correct? Anytime you have cubic unit, it's this value. What is the density in pound per cubic foot? And give you the units of conversion. That's a little bit more demanding, more work. I doubt it will come in higher chemistry. They might consider this, but in ours it's not. But it's not really difficult. So let's do it together. This one is just time consuming. We'll do it together. Here it is. Density is this, and we need to convert this one here in pound per foot, cubic foot. Now, from metric to what? To English. So let's start with the metric one. Kilogram per. I put the per there, so that's cube. Correct? So first you do it one at a time. You have the kilogram, the mass has to be converted from metric to English, and then we have to do the mass and the volume. Then we have to convert the whole thing. So let's do this one here. The kilogram at the bottom, 1 kilogram. Correct? It has how many? 2.20 pound. Now we have the pound in the top. So we have the pound here. There, it's appearing here. That's the pound here. Now we have to get rid of the cubic meter. Get into the foot. So we have, look at this. I have here 1 meter, and then I cube this one here. Has 328, correct? Foot. Now I have to be careful here. I cube this one here, so I have to cube this one what? As such. Okay, guys? Now I have to cube this, and I have to cube the foot. Correct? So now let's do the units first out. The units kilogram cancels out. Cubic with cubic meter will get out. So now we have pound, and we have this one here. So this one will be 0.164. Without unit, the units cancels out. 2.20 pound, correct? 1, and then we have here 1, no units, and then I have 3.28 cube and foot cube. So you have to multiply. The units are there now. The units are very nicely done. We have pound here, we have foot cube here, but then we have to multiply this value here by this divided by the cube of this value. So how much is it? Somebody will tell me. So how much? Come on, guys, don't let me down. First, get 3.28 to power 3. How much is it? So get this value here first. So, and then you multiply those together, divided by the cube value of this. So how much is it? So, do we have it? Let's try. I want to try as a team, work as a team. Work as a team. Yeah, work as a team, guys. So, work as a team. So which one? Yeah, the first thing is to get rid of the cube at the bottom, 3.28 cube. So get this value first, and then you can just do the multiplication and division. And remember, your answer has to have how many the significant figure? 3. All those are 3 sig figs. So we are expecting our answer to be 3 sig figs. So what option? Don't look. Don't look, please. Don't look. So everybody's giving up? No? That somebody else, because I shifted my camera a little bit. The answer was there. Nice try. That's a cheating procedure done here. Okay. So yeah. I saw you. So the answer A, but you have to convince yourself is this correct. The answer is A. Here it is. I did not calculate. It says A, and somebody, as soon as I did like this, somebody look at the answer. But I want you to convince yourself that's the correct answer. Everybody has it? Yes? Okay, trust you then. Okay. Okay, so let's do this one here. Answer is A. So here it is. Let's do this one here, guys. Oh, the answer came out quick here. Okay, so 20 irregular pieces of an unknown metal have a collective mass of this one here. That's the total mass. When carefully placed in a graduate cylinder, originally was at this empty, was 7.75. Final volume rate is 11.70. What is the density of the metal in gram per centimeter cube? Now, don't worry about the milliliter. Milliliter and centimeter cube are the same units. So here it is. The milliliter here and the cubic is the same thing. But centimeter cube used for solid and milliliter used for the liquid. So the answer is, the density is mass over the volume. Mass is 28.225 grams. Volume is the difference between 11.0 minus 7.75. So here is, you have to have 2 digits after the decimal. 2 digits, here 2 digits. So whatever the value here, this is centimeter or centimeter cube. Or milliliter. Those are the same unit. So, how much? Where is the answer here? C? Okay, C. Somebody says C. Everybody convinces C? Okay, so C. Let's see. Yeah. The answer is C, but I hope you did not cheat on me this time too. No? Okay, honestly. You are honest, okay. Okay, so answer C. Circle C. Now let's do this. You have palladium among nanoparticles has the density of this. What is the mass of a nanoparticle with a volume of this? Now those are the sub-formula, correct? Remember, the main formula is density over the mass over the volume. Now they ask you what's the mass. So out of this sub-formula, mass is density multiplied by the volume. Just watch out for the sig figs. correct? Luckily, those sig figs are 3, and here you have 3. The exponent has nothing to do with the sig figs. So 3, 3, our answer has to be 3 sig figs. So the answer is density multiplied by the volume. You get, come on guys, this is gram per centimeter cube multiplied by 1.8 for 10 minus 21 centimeter cube. Centimeter cube with centimeter cube cancels out. So how much is it? What's the answer here? How much? A? It's circled in front of me is A. Okay, that's good. That's good. Okay, that's A. Okay, guys. Okay, so let's see. Let's see. It's A. Let's do this one here. Oh, circle. Should not show you this, but it's okay. So I want you to be convinced. Which sample has the largest volume? Which one has the largest one? Should I do the calculation or not? You can do the calculation, but you can just look at the whole thing. The largest volume, and you have the density is given to you, and the mass is given to you. And I need the volume. So the volume is, oh, sorry, it's give you the answer, but we are not interested in the answer. So density is mass over the volume. I need the volume now, the second sub-formula. So the volume here is mass over the density, correct? So do I have to do calculation? Not really. I have just to compare those values. So mass, which is here 1 gram, divided by the density is, this is aluminum, correct? By 2.7, correct? And this one here, I'm not doing the unit, just aluminum is the density 2.7. Copper is, what's the copper? Divided by 9. This is divided by 9. So which one will be the largest ever of all those? Which one? So first of all, if you have this is at the bottom very large, then you can tell yourself this value will be small, correct? So the value has to be within the smallest number here at the bottom. Now, whether A or B, however, this is 5 and this is 1. So which will be the winner here? B. The answer is B, correct? Did I do any calculations? No. No need for calculation, just comparing the values. Because at the bottom I have 9, 9, so the 9, 9 is large value, so those are small values without even calculation. And then I have to look at the 2.7, but which one is larger, 1 or 5? 5, so this value will be the largest. So the answer is B, correct? The answer is B. Okay, guys, let's take this one out. Answer is B, correct? That's a good one. That's a good, very good one. So here it is. That will come in ACS exam, in your lecture exam, not in the lab, but the lecture exam will come something like this. They call it analytical, whatever. So analytical. So here how we do that. You have to sometimes by just looking at the picture. Now we have to calculate, make the ratio of them. Okay, guys. So we have what are the correct classification. Oh, that's classification, not the ratio. Okay, for 1 and 2 and 3. That's easy. That's even easy. So 1, 2, and 3. What we call this? 1 and 2 and 3. You have 1 is element, 2 is compound. That's option A. 3 is mixture. That's not correct. 3 is not mixture. This is not mixture. Where is the mixture? This is a mixture, correct? Guys, here, look. This is what? Mixture, correct? Okay. Which one is element? Which one is element? By itself. Element means all the atoms of this element have to be identical, not change. So this one will be what? Yeah. But if I have a different, that will be compound or molecule. Make sense? I have two different atoms. That's molecule or compound. This one's same. Same means it has to be element. And here we have spread out molecules. That will be a mixture. Okay, guys? Makes sense? Mixture, because one is solute, one is solvent. So which one will be then correct? Element, mixture, and compound. Where is it? Element, mixture. Yeah, the answer is B. Correct? We did not memorize anything, so let's see what they have. Answer is where? It's B, correct? Make sense, guys? Make sense what we did? Element, the same atoms, they don't change. The compound, you have two different what? Or three or four different atoms. The mixture, you have spread out of solute and solvent. Solute or solvent. So you have those here. So let's take another one. Here it is. Which diagram represents a heterogeneous mixture? That's easy. That's easy. Do you need to do anything of this? Where is the heterogeneous mixture? It has two phases. When you look at the beaker or the test tube, you see two phases. Which one? Without even looking. What's unique about this? Look at this. This is very, very strange behavior here. Means part of the solution, some solids are precipitating, correct? So this is a layer and this is another layer. Two layers. Two layers. That's settling down. But all of them are spread out, correct? And this is not a mixture, correct? That's you can take out this. And this is not a mixture. This is an element. This is a compound, and this is a mixture here. This one is a mixture, which is homogeneous. Mixture. And this is a mixture, but this time is what? Heterogeneous, correct. So the answer is this one here. Are you following me here? So those are not mixture. This is element. Element means the same atom, the same color. If I have two different colors, that will be what? Compound, correct? Same thing. And this is, we have something, two layers. A mixture, but we have two layers, different. And here they are homogeneous. We have a solute, see, and if this is a solvent, for example, or element, and this is another one, another element, whatever, or compound, that will be homogeneous mixture. So, okay, guys? So, any question? Any question? No? Okay. Which macroscopic representation best represent a solution? That's an easy one. A solution is made of solute, small amount, and the solvent, a larger amount. So which one? This one here, we said, this one we already decided, this is out of our consideration, correct? This is not a solution. This is a settled down solid, correct? And this is not a solution. Why? This is just an element by itself or molecule by itself. You need two types of circles, but then you have one is a solute, one is solvent. This can be a molecule by itself or solvent. That's not. So what's left? So this here small amount, 1, 2, 3, 4. This is the solute here. Then you can go and look at the ratio here. 1, 2, 3, 4, 5, 6. That's solvent. Okay, guys? So the answer is D. Make sense? Make sense? Okay, so you have to have two items inside the solution. A solution is a homogeneous mixture, by the way. So, okay, so answer circled, correct. Which of the following is a physical change? Making a pot out of a plate dough, the burning of propane, gas grill, baking cookies, a banana turns brown. Now, first look, they said physical. Physical means you can recover the stuff. If the banana turns brown, can you turn it to the original color? No. So that's a physical. If you are burning, using your gas grill and you are barbecuing anything, correct? Can you bring the original meat to its original raw meat? I mean, not cooked. No, it's already done deal. So that's combustion reaction. That's chemical. Baking cookies. Baking cookies, you have to use fermentation. The dough is coming up because of fermentation process. You have chlorine. You have carbon dioxide coming out. So the process is what? It's chemical. If you cook the cookies, can you return the cookies back to their original dough and sugar and ingredients back to their original stuff? No. They're done deal. These cookies, they are cookies. You cannot bring them back. Anytime I have the choice to return back the compound or the mixture or anything back to the original state, then yes, then it's a physical. So making a pot out of a blade dough. That's yes. You can reverse the process. Okay, guys, you can reverse the process. So the answer is A. Okay. An example of kinetic energy is a coiled spring, a running tap or a tree, natural gas. What is kinetic energy? Anything in motion. What is potential energy? Anything at rest. Now I'm talking to you, I have kinetic energy, correct? Because my hands move. But if I at rest here like this, so not talking, not moving, nothing, that's I have potential energy. So which one we have motion here in all those 4 options? Yes, that's the running one. That's the running one, correct? See it? You see it? Yeah, all the other ones are. A coiled spring is sitting there at rest. It's not moving, correct? But if, say, the coiled spring is jumping up and down, that would be kinetic. But it's just at rest. A tree at rest. Natural gas at rest. No, nothing is moving. But the only running and moving is H2O. So let's take this is conversion of temperature. So temperature of a summer day is measured to be 95 Fahrenheit. What is the temperature in Celsius? Well, this one here, I doubt it will come, but if it's coming, then remember the things we have. We said about the 3 systems. So we have 3 systems, guys. Just remember those 3 systems and the units between the difference between them. This is a Kelvin, start 273.15 Kelvin. That's the K, capital K, and it ends. We are measuring what? We are measuring from here. All those here temperatures are boiling H2O. We take H2O as a reference, boiling point. boiling temperature of H2O. And here, all of those here are freezing point of H2O. This one has to be in your brain. The Fahrenheit will start with 32, correct? Will end up 221. It's 118. 100. Is it 180? This is 100 degrees, 0 degrees, and 100 boiling Kelvin Fahrenheit. 200 what? 200. The difference between them is 218. So 0, 1, 2. Correct? Am I correct? 2, 2. 2, 1, 2. So here it is, 100. So that's what I want to see. I want to see 180 Fahrenheit equal to 100 centigrade Celsius equal to 100 Kelvin. This is what I have to memorize out of all this freezing and then 2 to 12, yeah. So this is the only thing. So don't worry about the whole thing here. Worry about this. So I have this. This is very important to memorize. So then I have to do here, since guys, look, let's do the whole thing now. I have give you this one here to do it from Fahrenheit to centigrade Celsius. Well, you have 95 Fahrenheit, correct? And you are going from 32 Fahrenheit to 0 centigrade Celsius. You are going down, correct? Are you following me? We are going down. So if I'm going up, I have to add. If I'm going down, I have to subtract, correct? I'm going down from 32 Fahrenheit English to 0 centigrade Celsius. So I'm going down with the scale. So I have to subtract. So subtracting this 32 Fahrenheit, then what's the difference between them? Then you have, I give you the formula here. Oh, that's easy. They give you the formula. But then plus, let me see. Yeah. That will come later on. So it is Fahrenheit. It's give you the formula here, but I want to show you how to do it with the scale. Use the scale. 95 Fahrenheit, correct? Okay, 95 Fahrenheit is, then you have to, 95, oops, sorry, it's this here. What is this? 9250 Fahrenheit. It's getting crazy. So 95.0 Fahrenheit. Okay, guys, I have to 180 Fahrenheit to 100 centigrade Celsius. So this one Fahrenheit cancels out. This is Celsius plus, correct, guys? Plus, no, that's what they give you. That's not correct. That's not correct. Yeah, no, that's not correct. They have to give you the formula like this. That's not correct, guys. Let's do it. Let's do it our way here. Our way. So 90. There you have to put this formula is not correct. So somebody will tell me why. TF minus 32 equal 1.8 TC, correct? So TC divide by 1.8, divide the whole thing by 1.8. So TC here is TF minus 32 over 1.8. So that's what they have here. Everybody's following here? So what I wanted to do, I take this TF here, I mean the Fahrenheit, and then subtract the 32, the Fahrenheit, and then add to it, add 95 here. This is what I want. Check with me if you can get the same thing I have. 95 Fahrenheit multiplied by 180 Fahrenheit plus 100 centigrade Celsius. Okay, so this is hold on. I don't want you to memorize this because when you come to memorize, then you will have a problem. 95.0 Fahrenheit minus 32 Fahrenheit, correct? So and then you have Fahrenheit 180 Fahrenheit to 100 centigrade Celsius. See what you can get, how much you can get out of this. So we get the Fahrenheit out of our way by subtracting. We went down by 32 and then use the scale here. Remember the scale? 100 centigrade Celsius equal 180 Fahrenheit equal 100 Kelvin. That's the scale you have to memorize. You don't have to memorize everything. So how much is it? Okay. Can I find the answer without even calculation? Somebody will tell me. Yes, I did not. I kept it for myself. Can I? Yes or no? Yes. What's the body temperature? 98, correct? The body temperature is 98 Fahrenheit, which is around 37 centigrade Celsius. So if the body temperature is 98 Fahrenheit, and the question is 95, so the answer has to be close to what? To the body temperature, correct? So this is not body temperature. This is not the body temperature. This is where it's not body. The only thing closer to the 37 is 35. Are you following me here? The body temperature is 98 Fahrenheit or 37 centigrade Celsius. Okay, guys? So without even calculation. But I want you to memorize this, not anything else. And then if you go from up to the lower one, subtract. If you go from the lower to higher one, you have to add. Okay, guys. So, but I doubt they will bring something like this because I don't know. I doubt because this is. So here it is, guys. Is a C, correct? Close to the body temperature. So question, which of the following describe the concept of absolute zero? Temperature at which H2O freezes? No, that's not absolute zero. That's a normal centigrade, 0 centigrade Celsius. That's not. So the temperature at which motion of all particles theoretically stops. That sounds. When I say absolute zero means absolute rest, correct? Absolute zero means absolute zero motion. So absolute rest. So the P is possible. So let's look at so first eliminate this one here. This one is eliminated. Oops. So let's eliminate this one here. This one will be eliminated because that's not absolute zero, correct? This might be, so we give it, means anything absolute zero means you have absolute rest. There's no motion, no nothing. The lowest temperature recorded on Earth, that's not true. The lowest is a North Pole somewhere, is minus 70 something degrees Celsius. So that's not correct. And the temperature in which a gas turn into a liquid. Temperature gas turn to liquid? No. So then our option is correct. That's what everything is stops. Correct? No motion at all. So then let's see here our answer. Our answer is correct. B, correct? Is it? Yeah, B. That's correct. sometimes you have to look and suggest one answer is very close to be real, but then look at the answer, the other answer, elimination by elimination. So, time now, a couple of minutes. So, liquid exhibit all these properties except liquid exhibit all liquids, all the liquids. Definite volume, incompressibility, slow diffusion, definite shape. Which one? So what's the shape of a liquid? Correct. Now, it's the shape of the liquid and the gas is the shape of the container they are in. Correct? Whatever the container is, if you have the container is a sphere, then the shape of gases and the liquids are sphere, correct? So, exhibit. So which one then is, which one we have to, the correct answer? Compressibility, they are compressible. Liquids and gases, not solids. Solids are not compressible. So which one? B? Did you look it up?
No, it's you just said it.
Okay. So somebody is opening the oops. Last one, and then I will stop here. Which of the following correctly describe the behavior of particles in solids, liquids, and gases as temperature increases? Which one? You increase the temperature of the gas, well, what will happen? Liquids and solids, what will happen? Liquids move faster. In solids, particles move farther apart and freely move past each other as temperature increases. In the liquids, particle vibrates, fixed but original move slightly. In gases, particle moves. Which one faster and which one is correct? D, you can eliminate by elimination. Slower, no. The higher the temperature, the higher the rate of motion, correct? Which one is correct? C, a gaseous particle moves faster and spread farther. Yes, that's correct. So I'll stop here. We'll meet then this Wednesday, the last day of review. We'll review further, and that will be the last day of review. Okay, guys? Thank you.